Yeah, so the second problem today from the medium bucket is Domino and Tromino tiling. So essentially what it is saying, you have two set of tiles, okay? One has only two bricks and another has three bricks, but in the form of a L. So this is called a domino and this is called a Tromino, right? Which is essentially a three brick layout and this is a two brick layout, right? Now, the problem is you are given a 2 cross n board and n can be anything, right? Now you have to tell in how many ways you can arrange these X's, these dominos and trominos such that the board is always filled. Is the problem clear or should I explain it in a different way? Let me share my whiteboard. So essentially the problem
by
is
2n board.
Yeah, I'm just going to explain the problem here. So you have two kind of bricks. One is this is a domino, and then you have another which is a Tromino, right? Now this is essentially a 1 cross 2, or if you look at reverse way, it's 2 cross 1, and this is another way of looking at Tromino. So right now you're given a board which has only 2 rows. Right, and suppose the size of the board is 1, 2, 3, 4, 5, 6, 7, 9. Let's say it has 9. So it has 1 column, 2 column, 3, 4, 5, 6, 7, 8, and 9. So this is a 2 cross 9 board. Now what we are told is we are asked to completely fill this 9 box, right? We have to completely fill this one, right? 9 box one. But now they're asking in how many ways using these two kind of tiles can you fill it, okay? So let's assume we have only, for the sake of understanding, let's assume we have only 3 by or 2 by 2 box, right? So how many ways can we fill it with either domino, tromino, or the combination of them?
We can fill it in two ways, like one only with dominoes because we have to fill it completely, so we can't use trominos. So we'll either place two vertical dominoes or two horizontal dominoes to completely fill this arrangement.
Right. So you have two options. One is this way, another is this way, right? Correct?
So how do we know this cow? The cow is 2. I mean, like, is that a cow is based on the? It's not based on the number of tile, or based on the number of the tile layout.
I'm sorry, I did not get your question.
I think what he's asking is, I'll explain if I try to. We are given a 2 by n board. So n is the number of dominoes, and we only have like 2 rows. We have to fill the board completely, only using these two given type of dominoes. So that's the constraint here. The board is only 2 rows and n number of domino columns.
Okay.
So I hope that was answered.
Yeah.
So the answer of this 2 by 2 is like we can arrange it in 2 ways.
Right. So this is one of the way, and this is another way.
So
right?
like 2, yeah.
So now let's look at a bigger section. For the sake of
Let's start with 2 by 3.
Yeah, let's start with a 2 by 3 one. That's fine. So how many ways do you think you can fill it up with dominoes, trominos, or any combination of them?
One is if we can place the L-shaped. One is in straight.
So we'll use the first one as L shape. What next?
And then rotated L.
Okay, then rotated L, right?
Yeah.
So this is one of the questions, right? And what else?
Yep. One is like dominoes, only two domino, arranging 2 horizontal and 1 vertical.
So 2 horizontal and then
and
vertical, right?
Vertical.
Right. And what else?
Um, I don't think so.
Would the
So
order matter? Like, can I, if I have like one vertical and two horizontal, is that the same or different?
Oh, that's a different layout, right? So we're talking about different ways to arrange it. If you have sorry, go ahead.
Go ahead, go ahead.
So I was explaining, if you have first two horizontal and then third as vertical, it's a different layout or different arrangement as compared to if you have a first one as vertical and then other two as horizontal.
Then we can do exactly that, like one vertical, two horizontal. And then
in the first,
In the reverse way, like one vertical first and then two horizontal, like that.
yeah,
Sorry, okay, yeah, go ahead.
like all one vertical and two horizontal.
Mm-hmm.
Then all
One
three
vertical and
verticals.
that's correct.
We can also reverse the first one, so we have another
Yeah.
layout.
Exactly.
Yeah.
Right. So anything else you can think of?
I think that's
That's
it,
it.
I guess.
Okay. So now somebody, as the problem is clear, so somebody would try to, take a hands on what is the approach or any idea about how this can be done.
One approach that I was thinking is that like this is the smallest problem that we can break it down. So let's say we are given any number. Let's say if we want to solve it for 4, right? So we already know that like for 3 for 2 cross 3 we can solve it in 5 ways, right? So we can we just need to find out like what happens when we add another space, right, for fourth. So if we know we can solve it in 5 ways, right, and then what will be left for, we already know for 3 spaces we have solved, right? For the fourth space, what we can do is like how many ways can we solve the for one option, right? So maybe we could like multiply it by like these 5 combinations into 2 because we can shift them by 1, right? And just add a vertical domino tile there. So the answer for that would be, I guess, 10.
So
Yeah,
let's think about, we have 2 by 2 right now, right? So before
yeah,
that we would solve 2 by 2 and we see there's 2 ways to solve it, and now it's
yeah.
3 by 2. Then how you extend from that?
Yeah, so for 3 by 2, like we have another solution for those Tromino tiles that come into play. Only when the number is greater than 3 do these Tromino tile combinations come into play. Otherwise, like if we have only 2 more spaces left, we can only use the vertical or the horizontal combinations. Both vertical or both horizontal. Like if we have less than 2 or 2 tiles, we only have like 2 permutations available. If we group it into like combinations of 3, maybe then we can solve it further. Like that's what I was thinking.
Yeah, I see that when we have 2 by 2, we have the first and the fourth diagram on the right, right? And I don't see how we can extend from that to build 2 by 3, because we have only 2 by 2, we have only 2 configuration.
Okay. So guys, can we look at it in a different perspective? Like if we have something built up, like suppose this is already a filled array, right? Suppose we have a filled array, right? And what is that, you can either from the end, can you either remove a domino or a tromino, right? And then try to see if there's a sub problem which can be recursively used, right? So let's assume we remove a domino from here. We are reducing the problem for finding the number of ways from n to n minus 1, right? So if there are suppose 10 ways to get this n minus 1 filled, all of the 10 will be applicable for n, because for each of the combination you're just adding one domino at that, right? Is it
Yes.
right? Let's suppose you're removing a tromino from there, right? Suppose you remove this one, and this one is removed. Then what does it give you, right? You're at the end, you're right now, just left with a n minus 1 state, but which is having one as a one partially filled, right? Partially filled section, which is this one, right? If you consider n minus 1 here, you have one partially filled section, one filled section, right? We'll see how we can get this state if we want to calculate how many ways are there to create this state. But right now, if I can say there is a way, if I can remove last tromino from the array, what I need is number of ways this structure like this can be created, right? And this will not be once, this will be 2 times. One for this sort of tromino, other is exactly opposite, right? Which will create a structure like this. Is it clear till now?
Yeah. But so how do you count? You count the number of plus the number of ways to create the previous configuration plus 1?
No, so if you say there are 10 configurations for previous state, so what you're supposed there, so let's assume there are 10 sequences, right? Okay. Which give rise to this one. And if you're appending every sequence, at the end of every sequence, you're adding T, which is Tromino, it's still the same number. So if you get the number for n minus 1, it's essentially same for n also, based on this condition, right? Everything we're appending just T at the end, right? So essentially what we're saying right now is, let's assume f of n is number of ways I can fill, number of ways I can fill till n columns fully, right? The full completion. And E of n is the ways I can partially fill the last section till n columns. So now based on these three, what we are saying is, if you want to calculate number of completely filled positions till nth column, what we need is to find number of total filled ways for n minus 1, which is essentially this state, because at the end we are just adding one domino at that, right? And what we decided were there were 2 states that we can create and use the tromino at the end. So 2 into number of ways I can create this partial array, this partial state of the 2 cross n, right? Partial state for n minus 1 rows, n minus 1 columns, right? Is this clear till now?
Yeah, I think we can move on.
Is everyone clear about this?
Not,
Can you repeat again?
yeah, not completely clear to me.
Sure. I know this is a bit different to
Yeah.
understand in the first place.
Yeah, the example which is the input 3, if we try to use
Let me
that
just,
next one.
yeah, let me just use that example. So let me do this thing. Suppose we have this 2 by 3 matrix, right? Which is essentially, suppose it's completely filled, right? Now there are the number of ways I can get the count of this is if I remove this one domino from here, right? So what is essentially left is a 2 cross 2 metric, right? And how I want to find the number of ways in this in which it is calculated, let's park it for now. The other way is I can reduce it by this much. Sorry, I can do this one, right? And this part is another Tromino which I am removing, right? Is that correct? Is that understood till now? Right.
Yeah.
So now in this we are left with a 2 cross 1 partially filled array or partially filled section till n minus 1 row. In this case, 2 rows, right? 2 columns, sorry, I'm sorry, 2 columns, right?
Mm-hmm.
Now we know for the base case 2, we know this is always going to be
Full.
2. So
Yeah.
there are 2 ways to create a 2 cross 2, right?
Yeah.
And there are for 2 cross, 2 cross this, there are always going to be only 2 ways to create this kind of metric also. So if you can create it this way, or you can create it this way. Is that correct?
Yes.
Okay. So now when we are here, we know how many ways, if we just use this one, now we are just, coming back from the, recursive condition. We know there were 2 ways to create this 2 cross 2, right? And we can use all those combinations to create a 2 cross 3 also. So we have 2 ways to create this sort of structure. So some combinations of 2 cross 2, and at the end, everything is attached with this. Yeah, is it clear till now?
Yes.
Okay. So now coming to this condition, the other one, right? Now, how can you create a complete array for this one? You can attach a Tromino to this, right? So the way we remove it, so we know for 2 position, there will be 2 ways to create this, right? Or rather there are 2 ways to create this, right?
Oh, are you talking about like you're just removing the Tromino in the way that you've mentioned in the first one, or are you considering those 2 possibilities as the rotated one? Yeah, once you
The one on
rotated.
the arrow.
The 2 rotated possibilities.
Okay, okay.
Right?
Yeah.
So now consider these 2, and then you can extend these also by the Tromino that you have removed. So what essentially you're doing is trying to find how many ways this can be created and just adding this Tromino at the end, which will give you again like 2. Right?
Yeah.
So the first I have a question. So the first Tromino you from the previous case is attached in 2 ways. and the new one can be attached in one way, right?
So sorry, for which case are you taking this one? This case,
So
bottom case or
for
the top case?
bottom case, for the Tromino,
Mm-hmm.
for
Mm-hmm.
n-1 case,
Mm-hmm.
like the existing case, like the previous case, you can attach it in two ways, which is on the
Right.
arrow, the upper and the lower one. And the new
Correct.
one can be attached in one way.
Right. So for each of them, there will be one possibility, right?
Right, right.
Either for
Okay.
this, either for that.
Right, okay, got it.
Right, which will give you again 2, and you can sum it up. So this will give you f of n, which was essentially the let me just, if I can go. So what we just did in the diagrammatic way was the equation that was generated on the this equation that we did. Just twice times of p of n minus 1. Correct? So this is, if we remove the domino, where we remove the last part here, whatever was there, and calculated this part recursively. And this one was where we took the two cases, like this one, and sorry, this one, and the other was this one. Right? Now the question arises, how can we find partial cases? Right? How can we find, if I know I need a partial state to calculate the final state, but I need at each step, I do need a way to calculate the partial state also. Right?
Hey Puneet, quick question.
Yeah.
So when we were deriving the value of 2 cross 3, did we reach to total 4 combinations just now? Because there were two cases in the top when we were using tile, Domino. And
No, we got 5 cases.
no, when we just used this, couple of minutes back, there were two pictures. One was on top and one was on bottom, right?
Let me check if I can get back there.
Yeah. Is it a control Y works?
Control Y is going only till here.
Yeah. If it works, then we can go there.
So, sorry, Roger, I did not get what you're trying to say. Should I clear the screen and try to it? Okay.
Yeah, quickly let's do that. You already know so we are deriving solution for 2 cross 3. We are starting with already for 2 cross 2. We know there are two ways, right?
Right.
And then you added a tile on right side. So there were two solutions, right?
Right.
And then you had you were using Trominos. So that gave you two ways again, right?
Right.
So what my question was, are we saying that?
I missed one case actually.
Exactly. So that's why I talked about it.
Oh, sorry. Thank you.
Yeah,
yeah, I actually missed one case. So we know this is so let's say this is the condition where we are removing this Tromino, and from here we are removing this Tromino, right? Now we know for this one, we are going to have one way to create this structure, right? From a 2 width, 2 cross 2 section, we can only have one way, right? So essentially for each of these, there will be one structure created, and this will give us 2, right? For till here we had derived this one, right?
Yeah.
Yeah.
Right. So there was one structure, I don't know if you remember, there was this structure that we had discussed. Not this one. Actually forgot the. Let me do it with the show it with the 4 one. It's really easier to. Right. So let's say we are removing this one. Okay. And then we are trying to create a structure like this. When we go one step back. So Roger, this is the case, right, which you are discussing.
Right. So if you, yeah, exactly same way, if you consider that your last block was two horizontal lines, two horizontal dominoes, then your problem will reduce to n minus 2. Like if you are calling fn as the main problem, then you have reduced it to fn minus 2, because that's what we are missing here.
Right. Because because the thing is, if you take n minus 1, there's no way you can get this structure in n minus 1 condition.
Yeah.
Right. So that's why we have to consider this slot also for calculation.
Yep.
Is that understood? So this structure which we're discussing, the last one, if we are taking only one domino from the last, we are considering a shape which will remove this part, which is essentially a single domino vertically, and then you can get what is created essentially from 2.2, which is complete. Now, if you take a Tromino like this L structure, you're still cutting one of those structures into half, right? Now, this structure where you have last two completely filled with horizontal, this you cannot get in any of the way that we have described till now, right? This structure, or this structure. That's why you have to take this structure and reduce your problem from n to n minus 2 also. Does this make sense? Or no?
Why n minus 2?
Let me, create these mappings. We have this 3. We have this another way of creating 2 by 3. We have this one way, another way of creating 2 by 3. Right. I'll just map each of the possible solution with the formula that will be created. And here is the 5th one, right? So this one, if you see, if I can cut this into vertical half, I can get a solution for these two using the first part of our equation that we discussed. I'll just remove the vertical domino and try to find how many ways I can use a 2 by 2 fully, right? This is our first part of equation. Now from the second part of equation, what I did, I removed a Tromino from the end. So in this, I can remove this Tromino and this Tromino, which will essentially take, what I'm doing is partially filling this till 2 of 2, right? This was second. But now if you see this one, this third condition, if I try to only take n minus 1 elements, what I'm doing is I'm missing a complete configuration, which is horizontal 2 elements. Both of them need to be horizontal, right? So that's why what we're doing is we are considering a phase. Instead of removing a vertical domino, we are removing 2 horizontal dominoes and then taking all the combinations that can be created before that, which is n minus 2, because the width of this domino will be 2. Is this better?
Yeah. Yeah.
So in last one, so you are saying you will be removing the 2 width, the domino with 2 width. So that's why it's n minus 2.
Right, that's correct.
Earlier we were removing 1 width one, so that's why it was n minus 1. Here we are removing 2 width domino, so that's why it's n minus 2.
That's correct. Because what we are looking is whatever is before that, it's completely filled.
Okay.
Right. Same way here. Everything what we are looking before is completely filled, completely filled. Only in this case, it's partially filled with one section or one part of the tile empty. Is this okay?
Yeah.
Now the only challenge remaining is how do we find this partial? How do we calculate the partial fills? Okay. Is that okay? Why do we need to find the partial fills? Do we understand that thing?
Yeah, we need to find the partials of all these dominoes to calculate our answer. Like, is this
Right.
like, yeah.
So suppose we have a filled 2 cross n bounded area. How can I create a partial for this? Like I want a section which is partially filled with n. So this is my n. Okay, and this is something, you know, before I want to create this structure from any of the existing structures. Let's assume there's nothing more. I want to create this. How can I do that?
Somewhere if we can check that the upper rows and the lower rows which are completely filled or not. Like here we have filled upper rows, but not lower rows.
So can we think in terms of, you know, if we have this structure at the end? Because anyway, we have to look in terms of Trominos and Dominos, right?
Yeah.
So what if this is nth row? Can you see any relation to what we are discussing for calculating folds, similar to that a relation for calculating partials? So if you see, for calculating partials till n, what you can do is whatever you have full till n minus 2, right? This will be n minus 1, this will be n minus 2, right? So all of these n minus 2, if you attach a Tromino to them, right, they will create a partial. Is that correct?
Okay.
And the other way to create a partial is if you already have a partial. So suppose you already have this as a partial. Now, can you remove a domino from it or add a domino to it? So if you want to create this kind of structure, only way you can do is attach this domino here. Right? So if this is n, and you want to find the partial till n, what you can do is simply take partial of n minus 1. So if you have calculated the number of ways you can get partials till this point, you can attach a domino to the other side, which is, you know, empty. You will get another partial, which is still n. Does it make sense now?
I'm a bit confused over here. So why we are going for n minus 1? Earlier we were going for n minus 2.
So that was when we were calculating the fully filled sections, right? Now what I'm doing is I'm trying to find partially filled sections.
So let me give one liner what he's trying to do, then it will make really more sense. What we are trying to deduce is a recurrence relation. So, you know, you are trying to find solution for the smaller values of n. And what Puneet deduced that there are two players here. One is like a full solution is could be solved with a couple of full solutions plus partial solution. So now he has a recurrence relation between two full solutions for sure, but it depends on a partial solution. Now he wants to somehow reduce that, like, you know, formula for that partial part to further smaller values. so that he can actually use dynamic programming or anything to go to the base case, and then he can, do a bottom up to figure out the solution. That is why now he's trying to look at, okay, what are the possible configuration for the partial ones, and what are the possible ways to create that partial ones from a smaller values. And then he is trying to deduce this formula. I mean, that is the context. Like if you know the context, then you will know why we are doing that. And then, there are only a couple of ways to do that. Right, Puneet?
Yes, that's correct. So essentially what I'm doing is you have a base case and how you can use already created cases to find out what will be your final result. So essentially that's what we are doing, taking a last section, removing that. Because if we are trying to find this and we somehow know the solution of this, we can just reuse that solution and get the solution for the next state also. So here, each of your state and the movement from one state to another is either adding a domino or removing a domino, or adding a Tromino and removing a Tromino. Right? So what I would suggest is go through the, I'll share one video. It's a Geek for Geek video and they have explained it really well. Probably I'm not that good at explanation of this problem, but they have explained it really well, how, the concept of dominoes visually also, and go through the solutions. It's a pretty straightforward solution, but just this thought process of building this entire, structure or configurations and looking at how they are related to each other, that's the time consuming process. Otherwise, the program in itself is very simple.
Can we assume it something like, let's say, at first stage, let's say, instead of going backwards, let's say if I'm trying to visualize it, is it something like I'm first placing on each level, I'm placing either a vertical block or a horizontal block, right? And then whatever the valid paths I can continue on, like if I place a horizontal domino, then I have to in the next step place an horizontal domino only, because I need to completely fill all
Right.
all the board.
Right. So what you're doing essentially is kind of backtracking.
Okay.
Right? Because you are trying everything and then looking if that make configuration, otherwise you'll remove it and then add it back.
Yeah.
What we are doing here is, we know that the final state is complete.
Okay.
And we are just using the states which can move. So it's like, you know the final state, you know the source state. And instead of moving from source to destination, right? And you know the transitions in between. It's a domino or a Tromino, right? What you're doing is essentially moving backwards. So instead of adding a domino or Tromino, you are removing a domino or Tromino.
Okay.
And trying to reach to some state which is again source.
So if I'm going to like summarize kind of a thing, like you're moving from all the valid paths instead of like, for in this approach we would be like ignoring or pruning the paths which don't yield to a full result. Instead what you're doing is removing one.
Exactly.
Yeah,
we'll never go to a situation where we have this kind of structure, right?
Yeah,
because we
you.
know it will somehow convert to this by adding either 2 domino or 3 domino.
Mm-hmm.
So we are just avoiding to go through those paths.
Okay.
Okay.